Hi everyone, welcome back. I'll continue midpoint theorem. I have uploaded two videos for midpoint theorem. In first video, I have discussed about the theorem. In second video, I have done sums related to midpoint theorem. There are some more sums where you need to prove the conditions using midpoint theorem. Question number 8 from exercise 11. Bit confusing but easier. ABCD is a parallelogram. And when you are given a parallelogram, please do remember opposite sides are parallel and they are equal. E and F are midpoints of AB and CD. Midpoints are given to use midpoint theorem. Straight line AF and BF meets straight line ED and EC in the point D, G and H. Prove that triangles are congruent, and second part you have to prove it is a parallelogram. Watch the video carefully. ABCD is a parallelogram. Means that opposite sides are parallel and equal. E and F are midpoints of the side AB and CD. You have lines passing through the midpoint. And these midpoints intersect each other at G and H. First part, question C is that prove triangle HEB. Triangle HEB and triangle HCF are congruent. You can prove it easily because you know they are parallel, sides are parallel, two lines are intersecting each other, E and F are midpoints. Since ABCD is a parallelogram, therefore, AB will be equal to CD. Opposite sides are equal. E and F are midpoints of AB and CD. AB and CD. Therefore, AE is equal to EB and FC is equal to DF. Midpoint means line is divided in equal halves. Therefore, AB is equal to CD. You have two parts of them. Therefore, EB is equal to FC. This side will be equal to this. Look at this example, it will be much easier. Suppose you take this one as 4. So if AB is 4, this CD will be 4. EB is midpoint means 2, 2. Midpoint means 2, 2. Therefore, we can say this side EB is equal to FC. But you have to use statement to prove it. You can't take numbers and prove it. Now write in triangle HEB and triangle HCF, HEB, HCF You have to prove these two are congruent. First one, vertically opposite angles are equal. Angle EHB is equal to angle CHF. Vertically opposite angles. Second one, you can take the side EB is equal to FC. You can write given. Third one, use parallel property. Since line AB and DC are parallel, this CF is taken as transversal. And as you have transversal, there are alternate opposite angles formed. Angle HBE is equal to angle HFC, alternate opposite angles. Therefore, triangle HEB is congruent to triangle HCF by angle side angle rule of congruency. The first part of proving. Use parallelogram, calculate this EB is equal to FC, and once you get this, then proving will be easier. Vertically opposite angles, EB is equal to FC, and then alternate opposite angles. Second part question says that to prove GEHF is a parallelogram. To prove GEHF is a parallelogram. See how do we prove it? We have already done E and F are midpoints of AB and DC. Therefore, AE is equal to EB, DF is equal to FC. Since E and F are midpoints of AB and CD, therefore E is equal to half of AB, FC is equal to half of CD, and we use the property of parallelogram. AB is equal to CD, opposite sides are parallel and equal, therefore we can write E is equal to FC. AE is equal to FC. Therefore, since it is equal and we have parallelogram, AE will be parallel to FC because they are sides of a parallelogram. Therefore, AECF is a parallelogram. Parallelogram. So we prove this is a parallelogram. Now look at this one. We got this is a parallelogram. Similarly, we can take this one and prove it is a parallelogram. Since E and F are sides, midpoints of AB and CD. Therefore, is equal to half of EB is equal to half of AB. Since they are sides of the parallelogram, so we can write DF is equal to EB and DF is parallel to EB. Therefore, EBFD is a parallelogram. We prove first one, parallelogram. Second one, we are proving parallelogram. Now, since G is midpoint of AF, therefore GF is equal to half of AF, first part. Similarly, H is midpoint of EC, therefore EH is half of EC. And we have already proved they are sides of the parallelogram. Therefore, GF is equal to EH and GF is parallel to EH. GF is parallel to EH, and when two sides are equal and parallel, we can prove it is a parallelogram. Therefore, GEHF is a parallelogram. Look at this and watch it carefully. If you don't understand, you can revise it again and again and then look at the figure carefully. Question number 10. Question number 10. Part 1. First part, 10A. Question says that in quadrilateral, AB is parallel to DC. E and F are midpoints of AD and BD respectively. Prove that G is also a midpoint of BC. ABCD. EF G, and prove 2 EZ is equal to AB plus CD. Look at the first part to prove G is midpoint of BC. G is midpoint of BC. You have to use this. You cannot directly do it because question has condition E and F are midpoint of AD and BD. Look at this. Since E and F are midpoints of AD and BD. Therefore, EF is parallel to AB. EF is equal to half of AB. By midpoint theorem, the line joining the midpoints of any two sides of the triangle is equal and parallel to the third side. So since EF is parallel to AB, similarly we can write EG is parallel to AB because same line is extending. EF is parallel to AB, so this EG will be parallel to AB. Now what happens here? Since it is parallel, the question has condition AB is parallel to CD. AB is parallel to CD, therefore EG will be parallel to CD. This line is parallel to this, it's already given in the question. We proved using midpoint theorem, EG is parallel to AB. So this AB is parallel to CD, so CD will be parallel to EG. Since FG now, FG is parallel to DC. FG is parallel to DC and F is midpoint of BD. Using converse midpoint theorem, line passing through midpoint and parallel to the third side is midpoint of the second side. Therefore, G is midpoint of BC. Proved. First you prove these two are parallel, then take EG is parallel to AB, and since AB is parallel to DC, so this EG will be parallel to DC, and the line is passing through midpoint and parallel to the third side, always passes through the midpoint of second side. This is what asked in the question to prove. Now you have to calculate the second part. Look at this now. Question says that find EG is equal to half of AB plus DC. We use triangle first. In triangle ABD, E and F are midpoints of ED and BD. Therefore, EF is equal to half of AB. Take it as number 1. Consider this now in triangle CBD. Again we write F and G. We have already proved G is midpoint. Are midpoints of BD and BC. Therefore, by midpoint theorem, FG is equal to half of DC. We know that now. Take it as equation number 1 by adding equation 1 and 2. By adding 1 and 2. When we add equation 1 and 2, EF plus FG is equal to half of AB plus half of BC. Left side added to left side, right hand side is added to right hand side. Now look at the diagram. EF plus FG is nothing but easy. We take half common, we get AB plus BC. Proved. It's not difficult using midpoint theorem. Midpoint, half of this, midpoint, half of this, add it up, take common, you'll get the answer. Question number 10. The last question I'll do from the exercise. Look at this question now. Question says that three lines are parallel to each other. Three lines are parallel, L, N, N. G is midpoint of CD, so you join it. G is midpoint of CD. Question says that find BG if AD is 6 centimeter. Whole length AD is 6 centimeter. You need to calculate this length BG. Right, in triangle. In triangle ACD. ACD. G is midpoint of CD. Z is midpoint of CD. Line N is parallel to M. Z is midpoint and these two lines are parallel. Therefore, B is midpoint of AC. Converse of midpoint, line passing through the midpoint of one side of the triangle and parallel to the third side also passes through the midpoint of the second side. Now we write BZ is equal to half of AD by midpoint theorem. Length of AD is given in the question. Half into AD is 6, 3 centimeter. The first answer. Second one, question says that calculate CF. Calculate CF when GE is 2.3. GE is 2.3. Now take triangle now. In triangle CDF. CDF. G is midpoint of CD and line N is parallel to L. These two lines are parallel. Therefore, E is midpoint of DF. Midpoint, parallel line using converse of midpoint theorem. Parallel means E is also midpoint. Therefore, GE is equal to half of CF. Length of G is given 2.3, half CF you have to calculate, cross multiply. CF is equal to 4.6 centimeter. Third one, question says that calculate the length of AB. total length AB you have to find when BC is 2.4. We have already proved B is midpoint of AC since B is midpoint of AC. Therefore, EB is equal to BC, 2.4 centimeter. Line passing through the midpoint and parallel to the third side also passes through the midpoint of second side. Last one, you have to calculate ED. ED when FD is 4.4. FD is 4.4, the total length. It's easier since E is midpoint of FD. Therefore, ED is half of FD, half 4.4, 2.2 centimeter. I have left few sums from the exercise. Please do try yourself. You need to practice, you need to solve the sums, you need to prove it on your own. Then only you will be able to understand the midpoint theorem. Thank you very much. Stay safe.